And welcome everybody to essentially in the textbook, it's lesson 10-10. We're going to talk circumference today. But first, if you're okay with it, and I guess if you're not, you're still going to get it. I'm going to show you heads up for the next couple weeks. What's highlighted in blue or light blue is the weekly schedule. And as you can see, circumference, area, volume, we are starting to get into the long-awaited geometry and measurement. Sooner or later, we get into surface area and volume. So we start with two-dimensional flat figures, get into three-dimensional solid figures, and then the big one on Monday the 29th, composite figures. Just like a compound is made up of more than one element, composite figures are often made up of more than one shape. Getting into chapter quiz and the test right before spring break. So I just wanted to show you ever so briefly that. Now let's go ahead and get into today's lesson. Once again, we'll call it 10A1, but really in the textbook, it's chapter 10, lesson 10, circumference. Focus for the day, I will understand the relationship between radius and diameter and calculate the circumference of a circle. So it's given over there on the right side in blue. If I give you either a radius or a diameter of a circle, you should be able to come up with its circumference. Now, what I'm actually going to do in class is to review area and perimeter of two-dimensional polygons. That would be two-dimensional shapes with, what would you say, with straight edges and angles. Squares, rectangles, parallelograms, triangles, trapezoids, and so on. We'll do that in class, and we'll review those answers. If you need to review those answers, you can look at them right now. Noticing that all perimeters are one-dimensional. It's like lining a ruler up and measuring around the outside, so that's why you get inches or centimeters or yards for perimeter. Notice all areas are two-dimensional. How many square inches of wrapping paper will cover these GIFs? Onward we go back to circumference. And if you'd like, pause, come on back when you're ready. I will explain what show all four lines means with the exact and the estimate coming up. Firstly, I want to review what a circle is because all too often students don't know what that circle is. So a circle is actually an infinite set of points, all the points on a two-dimensional plane that are equidistant from one center point. In other words, ladies and gents, if there's no center, there's no circle. All right? I apparently used text pen for that, huh? So let's go back to text pen. No center, no circle. And just to point out, when I say infinite, I mean an infinite set of points. If you come up with 2 points, we can come up with a point in between. Now we have 2 points, you can come up with a point in between. Now we have 2 points, you can come up with a point in between. Ah, the mystery of infinity. Now, radius. Radius is that, well, there's some debate in definition of a radius. Is it a line segment or is it the length of the line segment? For now, we're going to call it a line segment with one endpoint at the center of the circle, one at the other endpoint anywhere on the circle itself. Now, diameter, naturally, diameter would be the line segment that goes through the center and its 2 endpoints are on the outside. Please notice the diameter will be the longest edge, the longest line segment within any circle. Think about it. You go here or here or here, any of these will get shorter and shorter and shorter. You'll probably prove that later on in geometry class, that a diameter is the longest line segment within a circle. Now, please notice, therefore, that if a radius is the distance from the center to one point along the outside, that would mean this other half is another radius. So, diameter would be equivalent to, I suppose you could write 2r's, but why not just write 2r's? If you went backwards, you would say a radius is precisely 1/2 of the diameter. So that is part 1 of our objective for today, is understanding that a diameter is the equivalent of 2 radii, that's how you say it in plural, or that a radius is equivalent to 1/2 its diameter. All right, so what is circumference? Now, notice that I put the word perimeter here in quotes. I do that for a reason. See, perimeter is the length of the measure all the way outside a polygon, something with flat edges and angles. The circumference has no flat edges. It has no angles. Excuse me, a circle. Therefore, we're going to use the word perimeter in quotes here. So the circumference of a circle is the outside perimeter of the circle's shape. Now, something you need to know. First, when ancient mathematicians, oftentimes we talk Greeks, but there were other mathematicians throughout Egypt, ancient China. When ancient mathematicians kept examining the relationship of a diameter to its circumference, and if they ever took the ratio or divided it, they kept coming up with the same number over and over and over and over and over and over and over again, to the point where they just said, look, we know what this number is. It doesn't seem to stop. It doesn't seem to repeat. Let's just give it a letter. And since the ancient Greeks popularized this, they gave it the letter pi. So pi is, by definition, the ratio of a circle's circumference to its diameter. Now, this is any circle. It works for any size circle you make. Circumference divided by the diameter of that circle always comes to pi. Now, supercomputers that can do hundreds, if not thousands, of calculations every second, mathematicians have had supercomputers running for days, weeks, even months, and cannot find neither an end nor a repetition to pi. Thus, we'll call pi eventually an irrational number. The formula for the circumference of a circle, therefore, if you simply multiplied both sides of this formula above by the diameter, what would happen? Diameter divided by diameter cancel out. And so you see circumference is equal to pi times the diameter. Now, what if we don't have the diameter? Well, remember, a diameter is the same as twice the radius. Now, I don't know why they don't write twice the radius times pi, but after all, multiplication is commutative. You can change the order and still have the same quantity. So you may use either of these formulas, but I think what you'll find I'll use most often is twice pi times its radius. All right, now that we're through, let's actually go ahead with some calculations. We'd like to find the circumference of this. Well, 15 inches is not a compact disc. Maybe this is a record or something. So what we're going to do is we're going to write 2 times pi times the radius. Yes, I know you could have used pi times the diameter and it might have been a little quicker, but I'm going to show you what I will call in homework the 4 lines of your work. Number 1 is always writing the formula. Number 2 is going to be substituting in those numbers. So in this case, we can write 15. Number 3 is going to be simplifying. So why write 2 times 15 times pi when you could say, well, look, twice 15, Mr. Callan, is 30 times pi. And then the 4th is going to be the approximation. Now, I'm going to say this over and over again. The textbook asks you to approximate pi. Forget that. We can use a pi button that goes not just to the hundreds place, but the calculators that we have access to have tens, if not hundreds of digits of pi in their memory. So we're going to actually go to calculator here, 30 times pi. This is going to take a little while. 30 times, notice that we have the pi button over here, and we get the answer of 94.24777,961. You almost think it's going to repeat, it doesn't. And just because our calculator stops doesn't mean that the number actually does. So it looks like there's a lot more space, but a calculator will only show so many digits. Therefore, if we're going to look at this, it looks to be closer to 25 hundredths than 24 hundredths. So let's go ahead and write 94 and 25 hundredths. And don't forget, obviously, we're measuring the number of inches, not inches squared, not inches cubed. We're measuring the number of inches that go around this record or circle, which means I could write this. So once again, please notice that number 3 is an exact answer. Whatever that number pi is, 30 times pi inches is exact. But line number 4, okay, so that's a nice answer for number 3, but if we really want to measure this out, figure out how much ribbon could go around that disc or whatever, you're going to want some quantity that it's close to, and this one's close enough. So that, ladies and gents, is what we mean by the 4 lines of our homework. Line number 1, just write the formula of line number 2, substitute in the given information. Line number 3, write it exactly the answer. Line number 4, write it as an approximate. Let's continue on and do another example here. Now notice how this problem is similar to the last problem. We're both finding circumference. Both the last problem and this problem is going to have essentially 4 lines of work. And I'm going to choose to use the same formula for this problem. Whoa, wake up, Mr. Callan. Made a mistake and didn't even mean to do it. Let me finish this one and then I'll get back and we'll see if you caught that mistake. So 2 times pi times some number. What do they give us here? Well, this is a line segment with an endpoint on the outside and at the center. Therefore, 5 is the radius. So let's come up with an exact answer here. When we could write 2 times 5, oh, come on, Mr. Callan, that's 10 times pi centimeters. Notice that is an exact answer. So now let's come up with an approximate answer. We're going to go to our calculator, 10 times pi. Again, all of our answers are going to be slightly different from what the textbook gives us. 10 times pi, 31 and about 42, almost in the middle, but leaning a little bit to the right, 31 and 42 hundredths. And so there we have 2 different answers. One is exact, one is approximate. Now, perhaps you didn't notice, but perhaps you did notice the mistake I made because, quite frankly, I was just going too fast. Notice how these problems are similar. Notice how they are different. Circumference, yeah, got an exact answer, got an approximate answer, but wait a second. If I look closely, I should have noticed that that 15 is a diameter. Therefore, 15 is not the radius. So I'm going to go ahead, I'm going to erase this along with my exact, and then of course that'll change my approximate answer. Instead of a diameter of 15, remember that the diameter is exactly twice the radius. So if we cut 15 into 2 parts, cut it in half, you'd have 7.5 inches. Now, of course, 2 times 7.5 gets us right back to 15 times pi inches as the exact answer. Let's go ahead back to this. One thing I like about the Desmos calculator is you can just go back and delete. No, that's not what I wanted. And you can type in the number that you want. And naturally, 47 and 12 hundredths inches is our approximate answer. So again, you see the similarities, but the major difference, which do they give you, diameter or radius? So let's take that into account as we get through one more example. Diameter of a bike, 2 feet. How far will the bike travel in one rotation of its wheel? Now think about looking at a bike sideways, right? If you want to go one rotation, well, that's another word for circumference. So let's go ahead and write the formula. Let's go ahead and substitute in. Now, Mr. Callan sees if the diameter is 2, that would mean the radii is precisely half of that, or 1. So the exact answer, 2 times pi times 1, could be simplified 2 pi feet. Let's also come up with an approximate answer. 2 times pi should be simple enough. Again, you could simply erase your old work, write in a 2, and then you get the new answer. So 6 and 28 hundredths to the nearest hundredth place. And there you have it. Again, to repeat myself numerous times, 4 lines, excuse me, for your homework. Each homework problem should have the formula, should have you substituting in the number, should have an exact answer, and should have an approximate answer. If you wish, take some time to think about what keywords could be used when you're looking for circumference. We already heard rotation of a tire, things like that. And when you're ready, I'll have some problems for you guys to do. That's what I got, ladies and gents. Take care, do well, and let's grow.